Okay, further mathematical induction. There will be 2 questions in this video. First one, show that P of n is what? 7 to the power of n minus 2 plus 4 to the power of n minus 2 is divisible by 11 for all odd n is bigger than equal to 3. So step 1, we'll go with the prove true for n equals 1, but you can't use n equals 1 here because the obvious reason will be n is what? Bigger than equal to 3. So the smallest one we can get is 3. So I'm going to put 3 here, okay? And then I'm going to start the normal proving here. So I'll put n equals 3, and then 7, 3 minus 2, plus 4 to the power of 3 minus 2, and it'll be 7 plus 4, because that's 1, 1. That's 11, which is divisible by 11, which means it's true for n equals 3. Okay. Step 2, assume true for n equals k, and then we'll just have to put k instead of n, that's all. 7k minus 2, 4 to the power of k minus 2. Now, there's one more thing you have to add on to this, is 11m. So 11 is the common factor, so that we know whatever we get is divisible by 11. So for sum, n is natural number or positive integers. Alright, so number 3, the step 3, prove true for n equals. Now this is going to be a little bit tricky again. I can't use k plus 1 because what was it? The smallest k will be 3, wouldn't it? So in here, quickly, 3 plus 1, if we did the normal k plus 1, 3 plus 1 is what? Even number, isn't it? So we can't use it because all n has to be odd number. So if I do 3 plus 2 is odd because it's a 5. So I'm going to go with k plus 2. Yeah? Okay, so make sure everything is odd. So pk plus 2, instead of k, I'm going to put k plus 2 minus 2, 4 to the power of k plus 2 minus 2 equals, again, same thing happens, 11. I'm going to go with the capital P this time. You can choose any letter. For sum, oops, P belongs to natural number. Alright, now just be careful. I know you have urge to just make it into 7 to the power of k there, because 2 minus 2 is 0. Please don't do that, because what we have to do here is we have to use this, the step 2. And step 2 clearly has the power of k minus 2. So we need to keep this one within power of something k minus 2. So I'm going to write here, so to remind ourselves from the step 2. Equals 11m. So on the left hand side, push up a little. What I'm going to do here is k minus 2. I'm just going to swap this place, plus 2. 4k minus 2 plus 2. That way it looks like I'm keeping up with what I need to use. And then what I'm going to do here is I'm going to separate these. That's times. So watch what I'm doing, guys. So that's what I've done. Hopefully, if you can pause it and think about it and then come back, that'd be good. Now, that gives me, I'm going to have 49. And that, I can replace it, because if I change that one in terms of 7 to the power of k minus 2, 11m minus 4 to the power of k minus 2. So I'm going to, maybe I can replace it here. Okay, so I'm going to do that now. Okay, and then plus 16 k minus 2. So if I times that, okay, 49 times 11, I'll get 539m minus, don't times it, I'll go 49 times 4 to the power of k minus 2 plus 16 times 4 to k minus 2. So I can see it's like collecting like terms, guys. So if I do that, what do I get? I will get 33 minus 33. So 539m minus 33 for k minus 2. Okay? And that's, if I take the 11 as my common factor here, I will get 49m 3 dot. Hopefully you understood what I just done. Okay, so if you don't understand, pause it, go back and think about it. Now I'm going to make a P equals the whole thing here. K minus 2, which is divisible by 11. Therefore what? P, well, true for n equals k plus 2. Make sure you put 2 there. Okay, now that's not what we sort of finished there. We have to do something. Okay, I'm going to just put it up there so we can continue. And then I will go, but p to power of, no, power of p of 3 is also true from step 1, wasn't it? So therefore, I can say now, therefore p of n is true for all odd integers that is bigger than equal to 3 by mathematical induction. Okay, so that's done for the proof. Okay, so next proof I'm going to do is second one is this. Okay, so show that p of n is 9 to the power of n minus 8 brackets n minus 1 close the bracket minus 9 is divisible by 64, and for all integers is bigger than equal to 2. So our first step, prove true for, again, n starts with 2, isn't it? So make sure we do that. 2, so power of 2, 2 minus 1. If I do that, I will get, which is divisible by 8, therefore true for n equals 2. So that's not too bad. Second, step 2, assume true for n equals k. This is not a hard one. This is one of the easiest one. I'll just put p k dot dot power of k minus 8 k minus 1 minus 9. Now again, divisible by 64. I'm just going to stick with my same capital letters. positive. Okay. 3 will be prove true for n equals k plus 1. Are we okay with that? Yeah. For this one, it doesn't really matter for this one because it's not odd or even. Okay, so it's okay with that one. So P, we put that in. Okay, plus 1 minus 1. I'm going to change to P. Okay. Now I'm going to go with the left-hand side. So I'm going to look at just this part. Now remember, I think it's a good idea to just write it from step 2. That so I'm just going to make that as a subject. Plus 9. If I want to sort of simplify this further, something like that. 8k plus 1. Okay, so I'm just going to leave it like that. It's just easier for me later. So let's have a look. Now somehow I need 9 to the power of k here because I can just replace that one to here. So what I'm going to do now is I'm going to do this. Separate that. And then I'm going to separate this. That will be just 8k minus 9. Okay. And what I'm going to do with this, I'm going to replace that with 64m plus 8k plus 1. Minus 8k minus 9. And if I expand this one, 576, use a calculator if you need to. 8k minus 9, cancel, 576 capital M plus 64k. And I'm going to take the 64 out, that's what we want. If I do that, I will get that, which is therefore true for n equals k plus 1. But p to the power of 2 is also true from first step. And so therefore, move up here to make more room. Therefore, I can say P of n is true for all positive integers that is bigger than equal to 2 by mathematical induction. Oops. Okay, great. Well done.